try to simplify.
Yes, awesome. But how do I do it when it has a radical? Excellent. And of course, I will rearrange this. Please become allergic to negative leading coefficients and not in descending order. Not descending order. You don't have to write this in. I'm gonna put it in here nicely and neatly. So I'm allergic to this, and I will factor out -1 and put x minus 9 in parentheses. The denominator is the square root of x minus 3. So how do we proceed? Here's my hint to you. What does that mean? What am I hinting at?
Fill the denominator.
Okay, so I have to multiply and divide by the same quantity. Which quantity will that be?
X. Square root of x minus 3.
That will be a big problem. Because if I multiply by the square root of, then I will have the same thing, and this is x minus 6 the square root of x plus 9, and I haven't accomplished anything. I did not get rid of the square root. We are using which formula? It's the conjugate.
Are you rationalizing?
Yes, of course, we rationalize the denominator in this case. Very good. So then what do I multiply by? So do not copy the same thing, because you're going to get 3 terms and you're not getting rid of the square root. So what do I need to multiply by? And divide, because this has to be 1. What would that be?
Plus 3.
Very good indeed. Good. So I continue here. Why I put this circle or something so that you understand this part is just an explanation. The problem continues here. I would never use this if I continue line by line, but I have to jump over all this. So I have limit as x approaches 9, negative x minus 9. I copy the square root of x plus 3. Can anyone give us this product? This was what I wrote as the first day agreement. I mean, we should not have difficulties with these 3 special products. So if we get stuck on this, then what are we going to do with more difficult topics? Can anyone give us this?
X minus.
This is a squared minus b squared, right?
Yeah.
Good. So then?
9.
Good. Awesome. I don't have to state the restriction because this implies x not equal 9. Can anyone give us the limit? I apply now the limit operator and it's gone. This is the last step when I apply it. So can anyone give us the answer?
Root of x plus 3.
We are applying the limit.
9, yeah, 9, 3, 6.
Yes, with minus in front. Very good. Awesome. So the square root of 9 is 3. 3 plus 3 is 6 with minus in front, negative 6. Awesome. Is this okay with everyone? Any questions, please?
If the square root is not only x, including the 3, what we're going to do?
Do you see the difference between these two?
Yes.
Is that okay, Tess?
I can't see it. I don't know.
-6. Oh, I see, but it's -6. It's because you write it negative in there.
So, Tess, do you see the difference between these two? I muted everyone, so please unmute yourself. Do you see the difference between these two?
I see the difference.
Yes.
My question: if the x plus 3 then square root under square root.
So if you
Well,
have,
the same
you're
thing.
saying that if I have the limit like this, as x approaches 9 from this,
Yeah, if it is
9
under
plus 3 is 12, so the square root of 12. I mean, it's whatever it is. I can't change that.
My question is, can you go up a little bit?
Oh, yeah.
On,
Okay.
here on x, square root of x minus 3, if the
So if
square
this one
root
is plus, then you have minus here.
No, if it's the same, square root of x minus 3.
Yes.
Not only square root only for x.
Can you repeat the question? I'm so sorry.
If the square root is not only for x, including 3, what we're gonna do?
Oh, I see what you're saying. So that would be our next, that was the next thing. So if you have like this, x approaches 9, let's say negative x minus 9 divided by the square root of x minus 3 like this.
Yeah.
Okay, that's very simple. So 9 minus 3 is 6. The denominator is the square root of 6. The numerator is 0, so the answer is 0.
We don't have to multiple.
You don't have to do anything.
Okay.
So the numerator is 0. That's fine. The denominator is not 0. 0 divided by this is 0, and you're done. Is that better?
Thank you.
Good, very good question. I would have never thought of saying this if you didn't ask, so excellent. Good.
I have a question.
Any question? Yes.
So when you go back to step number 1 where you should plug it in, what are the actual steps that come after that? Is it like 1, plug it in, and 2, simplify, then 3,
Very good.
plug in
Awesome.
the limit?
Awesome question. So when I first plug it in, I identify the case I'm working on. That is a must. Because I don't know. If I don't plug it in, I don't know what to do. If it's 5, I'm done. If it's 5 over 0, then I have to look from the left and from the right because this is from either side. I have to see if it's 5 over 0, I have to see if from the left is infinity, from the right infinity, from the left negative infinity, from the right positive infinity, blah, blah, blah. Now, if it's this case, then as the second step, I look at the function. I see that the numerator is not in descending order. I also see that it has a negative leading coefficient. So I took care immediately of the numerator. There is nothing else I can do to the numerator. And now I focus my attention on the square root of x minus 3. And I say, okay, since this is too simple to mention, there is nothing I can do. I did the most I could do to this. Then I have to focus my attention on this. And now I have to dig deep through my algebra and say, okay, what is next? Well, the only thing I can think of is to rationalize. And if this is minus, then I have to rationalize with the conjugate. If this is positive, then I have to rationalize with minus. And then I multiply the tops and the denominators, and I get this. I realize that that's the problem, and I knew exactly what the problem was. X minus 9 is the problem. Once I eliminate x minus 9, the rest is, I'm home free. Because that is the problem. That is the quantity, the factor that creates 0 over 0 from the beginning. That was the issue. So I was hoping to get rid of x minus 9. It worked. And now I'm applying the limit. The square root of 9 is 3. 3 plus 3 is 6 with minus in front. And now the limit exists and is negative 6. See, that's why we call these indeterminate cases. For this particular example, 0 over 0 turns out to be negative 6. So these indeterminate cases are called no clue. No clue. C-L-U-E. No clue. I know I can't have any forecast. Anything can happen. This is simple. This is either infinity, negative infinity, or D and E. But this, anything can happen. And here it is. Very good discussions. I live for these discussions because that's why I'm here. Perfect. Is this clear now? Is it better?
A little.
What when you say a little, is it something that is not that needs
No,
to?
I understand all that algebra and stuff. I was just asking, like, is there like?
I don't
way
have
that
a
we can always-
recipe. No, it's a
There's no
very good
recipe.
question. I don't have a recipe. I can only say that this is the absolute first step. Although there are situations in which I have to simplify before plugging it in, it's possible. I cannot give a recipe because every function is different. See, on the first function with polynomial, I had to plug it in. On this one, I had to rationalize. On the rational function that we had last time, I had to factor. So I can't give a recipe. It depends on the function. Yeah, I'm sorry, but I can't give a recipe because it depends on the function we are looking at and the intermediate answer or the beginning answer that we get. Okay, so now let's take a look at something else. Still limits. Like 35, limit as x approaches infinity. So this is totally different situation. Over 3x squared plus 5. Why is it different? Well, we have never seen this before. We had last time a limit when x approaches negative 3 from a rational function. We had when x approaches 3 from a polynomial function. We even had a combination today of rational and a radical, but x approaches 9. All of a sudden, where is this coming from? Well, it is possible that we will be asked to find the tendency of this function when x increases without bound. That's what we say when x approaches infinity, when x increases without bound. So we want to see where this is going. It can go to 5, it can go to 1500, it can go to infinity, it can go to negative infinity. Anything can happen. So the first step is always, I shouldn't say always, sometimes, as I said, we have to simplify the function. But in this case, we have to plug it in. And you can say, what do I plug in? Imagine that you plug in infinity. So let's analyze the numerator, which is a polynomial. Which of these three terms is the most powerful one at infinity? Because if I have here 2, all terms count. If I have here 1, all terms count. But if I have infinity, only one of them counts. The other 2 are too small to mention. So, which one is the most powerful at infinity? Or negative infinity, doesn't matter. Which one is the most powerful?
That's squared.
Very good. So now I'm asking, where is the numerator going? When x approaches infinity, where is this going?
Like up.
Very good, infinity. Good. Same thing here, infinity. This is another indeterminate case. So we have two indeterminate cases that we've seen so far. As I said, there is a total of 7. 0 over 0 and infinity over infinity. What are they? What do they mean? No clue. That's what they mean. I can't decide. So here's how we work on this problem. Again, I'm putting something here so you know that this is some explanation. It's not part of the problem. Limit Sx approaches infinity. And do not look at the denominator. Tell me again, what is the degree of the numerator? The degree.
Two.
Very good. We will factor out x squared. And you can say you cannot. And initially I will say you're right. But then I'll show you that we can factor out anything from anything. Let's say I have x plus 2, and I want to factor out 1,000. And you can say, it's not possible. How can you factor out 1,000 from x plus 2? Very simple. I can. As long as this quantity times 1,000 is this, I can factor out anything I want. This times this is x, this times this is 2. From, I don't know, x minus 3, can I factor out a squared? Oh, yes, of course. As long as I have x over a squared and minus 3 over a squared. Yes, I can factor out anything I please. As long as the quantity in parentheses makes it right. A squared times x over a squared is x. A squared times negative 3 over a squared is negative 3. So enough of this. Coming back here, I factor out x squared. Can anyone give us 3 terms here based on what we discussed? 3 terms.